Alrighty, so with this example here, we are now asked to find the smallest order Taylor polynomial centered at x equals 1 that will approximate e to the x minus 1 on the interval 0, 1 so that the error is less than 1. So now what it's asking us is, instead of can we find a Taylor polynomial and then find the error, but how many terms do we need for the error to be less than 1? So we did this a lot with alternating series error bound. So the first thing we're going to do is we're going to look at what a Taylor polynomial for e to the x minus 1 looks like, some degree n. And I'm just going to show you what it looks like. You could calculate this by hand yourself. And then we would go on, okay? So the question is, what does our n need to be so that our remainder is less than 1, okay? And so we're just gonna have to test this out and see how this works, right? So we'll, let's pick n equals 1 to start, and we're gonna see what our error would be in that case. So if we're trying to find the remainder for the first degree Taylor polynomial, that's going to be less than or equal to the maximum of the second derivative, because we're going to look at the next term, for some z. In this case, they didn't give us where we're approximating it, so we're just, our z will be in this interval. Divided by 2 factorial times x minus the center squared. Now in this problem, because we are not approximating at a particular value, we're just approximating on this interval, okay, we have to pick an x for this one, and then we'll find our maximum. So e to the x minus 1 is also a exponential function. It just shifted right 1. So if we're on the interval 0 to 3, okay, because we can pick an x here, remember, we want this to be a maximum bound. So we want this to make sure that the number we get is not too small. So we're going to say, okay, well, in that case, we'll start at 3. If our approximation is at 3, then that will be the biggest value. So we're going to plug in a 3 here for the x. So this is guaranteed to be less than or equal to, if x is 3. This bound will definitely be less than or equal to that because of our x there. We have our 2 factorial. So then the question is, what is the maximum value of the second derivative? Well, if we look at e to the x minus 1, the derivative of that will be e to the x minus 1 times the derivative of the top, which is just 1. So it's just e to the x minus 1. So the second derivative will be e to the x minus 1. And so if we're going to find a maximum, the maximum on this interval of e to the x minus 1 is going to be at this highest point, right? So that will be at e if we plug 3 in. So plug 3 into e to the x minus 1, and we get e to the 3 minus 1. So this remainder of 1 is guaranteed to be less than or equal to e squared over 2 factorial times 3 minus 1 squared, absolute value. But that's going to be all positive. Now, if we type that into our calculator and figure out what this maximum error will be, we will get 14.778. And so if we use an 1 degree Taylor polynomial, our remainder is going to be 14.778. And that's not good enough. We want a remainder less than 1. So we definitely need to increase the number of terms. So I have a feeling we probably need to go up a couple terms, but we don't want to go too far because it will get small fast. So let's try 4. So if we go to 4, let's find the remainder for 4. So that's going to be the maximum of the fourth derivative for our z in the same interval. Again, we're going to use, x minus 1 to the 4th power over, I'm sorry, no, we should be looking at the 5th. because we're using the 4 terms. So this should be the 5th. This, again, because we don't have a particular value of x, on our interval 0 to 3, the biggest that this value will be when x is 3. So we're going to put a 3 in here for x. This will be less than or equal to that for sure. And then the maximum of the 5th derivative will be, well, the 5th derivative is still going to be e to the x minus 1. So it will be plugging 3 in there as well. So that's still going to be the same graph here when we're at the 5th derivative, right? So we're going to plug 3 in to get the highest value, and that's the same thing that we got right here, the e to the 2. 3e to the 3 minus 1, which is e to the 2. So that's going to be the same. The only thing that's changed here has been the factorial. So now type this into our calculator, and we'll get 1.9704. So our error is getting closer to 1, okay, but 4 terms is not enough. So let's see if 5 is enough, because I think that might be enough. We're pretty close to 1. So now let's calculate the remainder if we use a 5th degree Taylor polynomial. So we'll look at the maximum of the 6th derivative. The maximum of the 6th derivative is still going to be e to the x minus 1. So the highest value that will still be when you plug in 3. So this will still be e squared. Same thing that we had when we plugged in e to the 3 minus 1. This will now be over 6 factorial, and again, we're going to plug in 3 because that's the highest our x value would be on the interval. And remember, this is a bound. Type that into our calculator, and we should get 0.6568. So now, is our error less than 1? Yes. So we know that we need to use a 5th degree Taylor polynomial. We need n to be 5. So we want to use a 5th degree Taylor polynomial. And that will make our error less than that. So there's not really a way to solve here. You can solve. Some people will try to solve the inequality for n plus 1, but it's kind of hard to do because of the whole maximum thing. So that's why the best thing to do is just guess and check.